So, like I mentioned in class today, there will be problems on your quiz this week that are like these two last examples from our notes. So let's go ahead and get through these. One question will ask us to use the slope to determine if triangle ABC is a right triangle. And if you recall, in order for it to be a right triangle, it needs to have one right angle. And for it to have one right angle, that angle must be, you have two segments that are perpendicular. For perpendicular lines, our slopes have to be opposite reciprocals. So, what I want us to do is first draw a right triangle. I'm not particularly concerned about what you label your vertices here. One of them has to be A, and use the coordinates as well. One of them has to be B, and the other one has to be C. I'm not particularly concerned as to what order you put them in. I want us to see that we have to check the slope of three different lines in order to solve this. So, well, that's exactly what we have to do then. I'm going to first find the slope of this line here, AC. And I'll write that this way, line underscore AC equals, and then I'll put point A is 3, 4, point C is 1, negative 2, and now I can solve for the slope like we've been doing in class. To get from 4 to negative 2, I'm going down 6, so that's a negative 6. From 3 to positive 1, I'm going down 2, so that's a negative 2. So that gives me a slope for line AC of negative 6 over negative 2, which is positive 3 over 1. I'm going to leave it as a fraction that way. It'll be easier for us at the end to determine if any of these lines are perpendicular. So I'm going to write next to here that the slope here is 3 over 1. That way I know, it's a visual cue, that I still have two more slopes to find. So that's one slope. Now I can find the slope from A to B. So M of AB is, I use point A, that's 3, 4. Point B, that's negative 3, 4. My jumps from 3 to negative 3 is going down 6. From 4 to 4 is 0. That gives me a slope. My change in y is 0. My change in x is negative 6. My slope, because the 0 is in the numerator, not denominator, is 0. So I have a slope of 0 for line AB. And the third one we have to check is line CB. So when I check the slope of CB, I use the point C, 1, negative 2. Point B, negative 3, 4. And I find the jumps again. 1 to negative 3 is going up 4. That's a positive 4. Negative 2 to positive 4 is going up 6. So that's a positive 6. I calculate my slope, and I get a slope of 6 over 4. Oops. Make that a 4. Simplify the fraction, and that's 3 over 2. So my slope here is 3 over 2. In order for this to be a right triangle, we said that it needed one right angle, which meant two of our lines were perpendicular, which meant I needed opposite reciprocal slopes. They're all positive or 0, so there's no opposites. Right away we can tell that there are no right angles. This is not a right triangle then. In order for it to be a right triangle, if this was 3 over 1, this would have needed to be negative 1 over 3. Or vice versa. If this was 0, one of the others would have needed to be undefined. So it's only a right triangle if you have opposite reciprocal slopes somewhere in the triangle. If it's not a right triangle, and that's how we would answer this question. Moving to the next problem, we're going to combine these ideas. The idea of being perpendicular, so opposite reciprocal slopes, and the idea of bisecting something. We talked about bisecting being dividing something into two congruent parts. In this case, we're going to be talking about segments. So when we bisect a segment, we divide it into two congruent segments. We're putting those together to come up with a perpendicular bisector. A perpendicular bisector is a segment with opposite, reciprocal, slope that intersects another segment at its midpoint. So two concepts here that we're working with. Perpendicular lines, so opposite reciprocal slopes, and midpoints. We are going to have to remember for the quiz how to find both of those. The quiz will be set up so we walk you through these steps as well. First step on a problem like this, if I want you to draw the perpendicular bisector, or if I want the equation of the line of the perpendicular bisector, any of those types of questions, the first idea is going to be to find the midpoint of the segment. So if my segment is segment AB here, I need to find the midpoint. In order to find the midpoint, we need to remember the midpoint formula, and that's where we take our x-coordinates and average them. And then take our y-coordinates and average those as well. Substituting in, this is an x and this is an x. So I'll have -1 plus 3 over 2 as my new x-coordinate. Here's a y, here's a y. It's -3 plus 5 over 2. Simplify these fractions and I get my midpoint is now at 1, 1. I want to go in there and put my midpoint on this graph and see if it makes sense. 1, 1 is right here. So what we've done is we've cut that into two congruent segments. And that looks about right. So visually we can tell it looks right, but we can't trust visually all the time. We do know that that point is on that line, and it does look like it is cutting it into two congruent segments, so we know we're correct. So far, that's all I know. Now, if I want the perpendicular bisector, though, we've bisected the segment. I now need it to be perpendicular, so I need to calculate the slope of the segment. Two ways to do this. Back in Algebra 1, we learned that when we're calculating the slope, we can count our rise over run. So from point B to get to point A, and I always work from left to right when I'm counting it out, and I always rise before I run. We're going up 1, 2, 3, 4, 5, 6, 7, 8. So we go up 8 first, and then we run 1, 2, 3, 4. So another +4. That would give me a slope of rise over run 8 over 4, which is 2 over 1. The other way we could have done that is to use our slope formula, or take our points, -1, -3, and 3, 5, to calculate out our jumps. From -1 to 3 is a +4, from -3 to 5 is a +8. We get the same thing, a rise of 8, a run of 4, which would simplify to 2 over 1. So we have the possibility to do that a couple of different ways. That only interests me so far as it can tell me what I need about my new line. I need my new line to be the perpendicular line to this one. This one has a slope of 1/2, which means that the slope of any line perpendicular to it would have to be the opposite. So this is positive, this will be negative. And the reciprocal, that's 2 over 1. This will be 1 over 2. Important steps now. I take the point that I do know is on this new line because it intersects at this point here, and the slope of my new line, and I can write my new equation. The new equation of this line, with a slope of -1/2 going through the point 1, 1. 1, 1 is not my y-intercept. I know that because this is a 1 and not a 0. So I have to start in point-slope form. Y minus something equals my slope times x minus something. Those somethings are the x and the y from here. They're both 1, so I can substitute 1 in. I have to distribute. Y minus 1 equals negative 1/2 x plus 1/2. Negative times a negative is a positive. And then I scroll to the end here. My last step will be to add 1 to both sides. And while I'm adding fractions here, negative 1/2 x, 1/2 plus 1 is 3/2. It's positive. You can do 3/2. You can do 1 1/2. You can do 1.5. Any of those would be fine. That's the equation of your line. That should be your answer. And just to get a visual of that, I think it's easier not to graph from this because it'll be difficult to graph from a y-intercept of 3/2 or 1.5. We know this is a point that's on our line, and we know this is the slope. So I'll apply this slope from this point. I'm going to do this one in a different color. I'll use purple for this. Here's the point 1, 1. And I'm going to apply the slope of negative 1/2, so a rise of negative 1, a run of positive 2. A rise of negative 1, a run of positive 2. The other way we could have looked at it is a rise of positive 1, but a run of negative 2. And as we see when we draw our line here, this does appear to be perpendicular, and we can tell for sure because of our slopes are opposite reciprocals. So to recap, these will be on your quiz. Justifying that a triangle is a right triangle or not, we have to check for 3 slopes. You have to check for the slope of all 3 sides of your triangle. So slope 3 times, and you need a opposite reciprocal slopes in order for it to be a right triangle. That's justification. Perpendicular bisector, first find the midpoint of your current segment. Second, the slope of your current segment. Third, identify the perpendicular slope. Fourth is write your equation. You can always graph from your midpoint and your perpendicular slope. Please send me a message via email or Edmodo if you have questions. I am available before school on Wednesday and Thursday. I'm available after school on Wednesday as well. Come to the math office if you'd like to have any extra help. Thank you.